Hello and welcome back. This is Saxon Math Course 1. This is Lesson 3, Ratio and Rate. It's a new concept. A ratio is a way to describe a relationship between numbers. If there are 13 boys and 15 girls in a classroom, then the ratio of boys to girls is 13 to 15. Ratios can be written in several forms. Each of these forms is a way to write the boy-girl ratio. There's 13 to 15. This is also 13 to 15. This is 13 to 15. Each of these forms is read the same, 13 to 15. In this lesson, we'll focus on the fraction form of a ratio. When writing a ratio in fraction form, we keep the following points in mind. Number one, we write the terms of the ratio in the order we are asked to give them. Number two, we reduce ratios in the same manner as we would reduce fractions. Number three, we leave ratios in fraction form. We do not rate ratios as mixed numbers. So example 1, a team lost 3 games and won 7 games. What is the team's win to loss ratio? So it has to be in that order, win to loss. So we can see that they won 7 games and they lost 3 games. So this would be the ratio, win to loss. It could be written like this, 7 to 3, or it could also be written like this, 7 to 3. Or if you're typing it, you might think of it like this too, 7 to 3 also. Example 2, in a class of 28 students, there are 13 boys. What is the ratio of boys to girls in the class? And that's a question. So you have to keep it in that same order. So it has to be boys to girls. So in that order. So I can see clearly 13 boys is the first one. What's not so clear is how many girls. Doesn't tell us how many girls there are directly, so we have to recognize that it's an indirect thing and subtract that. We've got 5 here, this would be 1. So that means there's 15 girls, so the ratio would be 13 to 15. It could also be written like this, 13 to 15, or it could be written like this, 13 to 15. All of those would be the same ratio of boys to girls. Now if it said the opposite of that, if it said girls to boys, then you would have to go in that order, girls to boys, if the question happened to say it that way. And then you just have to recognize that there's 15 girls and there's 13 boys. So that'd be 15 to 13. And that'd be 15 to 13. This would all be the ratio if we're looking at girls to boys. If we're talking boys to girls, as it said initially, then you have to keep it in that order, boys to girls. If it's written in girls to boys order, then you have to write it in that direction. We're also looking at rate in this lesson. A rate is a ratio of measures. Below are some commonly used rates. Notice that per means for each. Per is a word that means for each, and it substitutes for the division sign. So, for example, if you're looking at speed, you notice that there's distance divided by, that's what this line means, distance divided by time would be written, say, for example, 55 miles and you did it in 1 hour. That would be 55 miles per hour. Sometimes it's mph. We can also look at mileage. We can look at distance divided by the fuel that was used. For example, 28 miles and you use 1 gallon, that'd be the same as 28 miles per gallon. Sometimes written like this, mpg. And you could have unit price, where you'd have the price divided by a quantity to tell you how much per the quantity, like what the rate is. So if it's $2.89 for every pound, It's $2.89 divided by a pound. That's $2.89 per pound. And per just substitutes for the fraction bar or the division sign. Rate problems are a type of equal groups problem. The rate is the number in each group. The problem often refers to will involve three numbers. One number is the rate, and the other two numbers are about the measures of that form, about the measures that form the rate. The three numbers are related by multiplication or division as we show below. So for example, if you have a distance, you want to find the distance of something, and you know how long the distance is and how much time it took, you can figure out, for example, 165 miles is how far you will go if you go 55 miles per hour for 3 hours. So if we're going 55 miles in every hour, that's the distance divided by time. The distance divided by time is 55 miles per hour. The number of hours you might go is 3 hours. So 55 miles, and that would be written like this. 55 miles would be up in the top, per hour would be on the bottom, and then if you multiply it times 3 hours, what's left once you cancel out things, this cancels this out, and now all you're left with is 55 times 3, which is 165, and then the label is going to be miles. In a rate problem, one of the numbers is unknown. We find an unknown product by multiplying, and we find an unknown factor by dividing the product by that unknown factor. So, for example, on a bike trip, Jeremy rode 60 miles in 4 hours. What was his average speed in miles per hour? So he's going 60 miles per 4 hours. So that's going to tell us if we take 60 miles divided by 4 hours, we'll actually be able to figure that out. And so I'm going to do the numbers here, and whatever the numbers are, it's going to be miles per hour is going to be my label, because miles and hours don't cancel. And what I see here, I've got this miles per hour. It's almost like it's already written for us. We just need to do the 60 divided by 4 to determine what the number is. 1 times 4 is 4. That'd be 2. Bring the 0 down. 20 divided by 4 is 5. So this would be 15 miles per hour. And ideally, we wouldn't have an S on the end of there, so it'd be miles per hour. In example 4, Mr. Moskall's car averages 32 miles per gallon on the highway. Predict how far he can expect to travel on a road using 10 gallons of fuel. So in this case, you know that he has a certain number of miles he can go for every single gallon. So if he's going a distance, so let me just write this, he's got a distance that he's going to go, and that will be the same as the distance he can go per the fuel used for each gallon, or whatever it might be, times the fuel used. So in this case, we are given the rate and the fuel used. We know that he has 32 miles per gallon. So that we know how much he used. He used 10 gallons. So if he went 32 miles per gallon, let me just write MPG, and we know that it's 10 gallons that he used. So in this case, I'm going to see that I would end up having 320, because I know what 32 times 10 is, just adding another 0. That'd be 320 miles. And how did I know what my label was? Because if I have miles per gallon, and I multiply it by gallons, this cancels out that, and all I'm left with is miles. So miles would be the only thing, and that's what miles per gallon is, that. All right, let's try this a few times. Letter A, what is the ratio of dogs to cats in a neighborhood that has 19 cats and 12 dogs? Go ahead and answer that. Let me set it up for you though. Dogs to cats. It has to be in that order. Dogs to cats. Now go. Now, if you notice, it gives you right off the bat, it tells you how many dogs there are, and it tells you how many cats there are. So there's your ratio. Can these be reduced? That's the question, I guess, that isn't asked, but you have to consider. It's 12 to 19. 12 is an even number. It's only divisible by 1, 2, 3, 4, 6, and 12. 19 is a prime number, actually. It's only divisible by 1 and 19, so it does not have any compatible factors. So this is the reduced amount here, reduced ratio for letter A. Letter B, what is the girl-boy ratio in a class of 30 students with 17 boys? So this one, you have to have it set up. It needs to be in that order. Girl to boy ratio. So the girl-boy ratio, I see that there's 17 boys, so I'm going to write that over here to begin with. I don't know how many girls there are, but indirectly I know what it is, because 30 minus 17 will tell me how many girls are in this class. So there's 10, that'd be 3, so that'd be 13. So there should be 13 girls and to 17 boys. Now that ratio, you could have written it in a number of ways. It could have been 13 to 17. That would have been correct. Or you could have written it 13 to 17. That also would have been correct. Up here, you could have done the same. You could have had 12 to 19 with the word to, or you could add 12 over 19. Letter C, if the ratio of cars to trucks in the parking lot is 7 to 2, what is the ratio of the trucks to cars in the parking lot? So for this one, letter C, all you need to do is recognize that it's in 7 to 2. Cars are 7, trucks are 2, and it just wants us to flip it. So the ratio would be 2 to 7 if we're talking about trucks to cars. It could be 2 to 7, or it could be 2 to 7. So those would be all correct answers that way. Letter D, it's a rate problem. How long will it take a trucker to drive 400 miles at 50 miles per hour? So in this one, you just have to consider that he has 400 miles and he's going to go 50 miles in every single hour. So in this case, you'd have to take that 400 miles divided by 50 miles, which in this case, when you do that, 400 divided by 50, one thing you could do, you could recognize that this will cancel that out. Now all I have left is 40 divided by 5, and that would be 8. So in this case, the answer would be 8 hours is how long it would take to travel that 400 miles. So that distance was 400 miles, and that's the same as if he's going 50 miles per 1 hour, and he's going to do that for, an unknown amount. We didn't know that it was 8 at the time, but in this case you would just take 400 divided by 50. Letter E, if a 4-quart container of milk costs $2.48, what's the cost per quart? So in this one, you need to think about that first particular price per quantity. So if you've got the price divided by the amount, you can find out what it would cost per quart. So if it's $2.48 in total, what's the cost per quart? It's 4 quarts, and it's $2.48 for 4 quarts. So we have to take that $2.48 divided by 4. And in this case, the decimal comes straight up in the answer. It would be 6, and this will be a label. Then it'd be 24, subtract that, and we'd have 0. Bring that down, it'd be 8. This would go in there 2 times, it'd be nothing left over there. So it'd be 62 cents per quart is how much we're paying if it costs that much for 4 quarts. And if you want to double check your answer, you just take the 62 cents times 4 to see if it ends up being $2.48. And that's what it does when you move the decimal over. So that would be it. All right, thanks for watching, and make sure you do your math during the math class. You've got 30 problems. That'll be 50 minutes to complete that. This should be completed during your evening hours or during your study period or outside of designated math time. This is technically your homework. All right, thanks for watching.